Hello guys, and welcome to my channel. In this session, I want to talk about system requirements definition process. Well, let me invite you to the training session number 15, and as always, have a good one. As stated in ISO IEC IEEE 15288, the purpose of the system requirements definition process is to transform the stakeholder user-oriented view of the desired capabilities into a technical view of a solution that meets the operational needs of the user. System requirements are the foundation of the system definition and form the basis for the architecture, design, integration, and verification. Each requirement carries a cost. It is therefore essential that a complete but minimum set of requirements be established from defined stakeholder requirements early in the project lifecycle. Changes in requirements later in the development cycle can have a significant cost impact on the project, possibly resulting in cancellation. The system requirements definition process generates a set of system requirements from the supplier's perspective using the stakeholder requirements that reflect the user's perspective as the basis. The system requirements specify the system characteristics, attributes, functions, and performance that will meet the stakeholder requirements. Requirements definition is both iterative and recursive. According to ISO IEC IEEE 29148 Requirements Engineering, when the application of the same process or set of processes is repeated on the same level of the system, the application is referred to as iterative. Iteration is not only appropriate but also expected. New information is created by the application of a process or set of processes. Typically, this information takes the form of questions with respect to requirements, analyze risks, or opportunities. Such questions should be resolved before completing the activities of a process or set of processes. When the same set of processes or the same set of process activities are applied to successive levels of system elements within the system structure, the application form is referred to as recursive. The outcomes from one application are used as inputs to the next lower or higher system in the system structure to arrive at a more detailed or mature set of outcomes. Such an approach adds value to successive systems in the system structure. Thus, iteration between this process and others is expected as more information is available and analysis is performed. This process continues to be recursively applied to define the requirements for each system element. The output of the process must be compared for traceability to and consistency with the stakeholder requirements without introducing implementation biases before being used to drive the architecture definition process. The system requirements definition process adds the verification criteria to the defined system requirements. Below figure is the IPO diagram for the system requirements definition process. Note that inputs and outputs for the system requirements definition process are listed in this figure. The system requirements definition process includes the following activities. Prepare for system requirements definition. Establish the approach for defining the system requirements. This includes system requirements methods, tools, and the need for and requirements of any enabling systems, products, or services. In conjunction with the architecture definition process, determine the system boundary, including the interfaces that reflects the operational scenarios and expected system behaviors. This task includes identification of expected interactions of the system with systems external to the system or control boundary as defined in negotiated interface control documents or ICDs. Define system requirements. Identify and define the required system functions. These functions should be kept implementation independent, not imposing additional design constraints. Define conditions or design factors that facilitate and foster efficient and cost effective lifecycle functions. For example, acquisition, deployment, operations, support, and retirement. Also, include the system behavior characteristics. Identify the stakeholder requirements or organizational limitations that impose unavoidable constraints on the system and capture those constraints. Identify the critical quality characteristics that are relevant to the system, such as safety, security, reliability, and supportability. Identify the technical risks that need to be accounted for in the system requirements. Specify system requirements consistent with stakeholder requirements, functional boundaries, functions, constraints, critical performance measures, critical quality characteristics, and risks. System requirements may be captured in the SYRS. Additionally, a documentation tree may be developed to define the hierarchy of system definition products being developed. The documentation tree evolves with the interaction of the system requirements definition, architecture definition, and design definition processes. Capture the associated rationale as the requirements are specified. Analyze system requirements. Analyze the integrity of the system requirements to ensure that each requirement or set of requirements possess overall integrity. Provide analysis results to applicable stakeholders to ensure that the specified system requirements adequately reflect the stakeholder requirements. Negotiate modifications to resolve issues identified in the requirements. Define verification criteria, critical performance measures that enable the assessment of technical achievement. System verification criteria include measures of performance or MOPs and technical performance measures or TPMs, which are the implementation measures of success that should be traceable to the MOEs and MOSs operational perspective with the relationship defined. Manage system requirements. Ensure agreement among key stakeholders that the requirements adequately reflect the stakeholder intentions. Establish and maintain traceability between the system requirements and the relevant elements of the system definition. For example, stakeholder requirements, architecture elements, interface definitions, analysis results, verification methods or techniques, and allocated, decomposed, and derived requirements. Maintain throughout the system lifecycle the set of system requirements together with the associated rationale, decisions, and assumptions. Provide baseline information for configuration management. In Continue, I will elaborate and provide how-to information on the requirements analysis and management. Requirements definition and analysis, like the set of SE processes, is an iterative activity in which new requirements are identified and constantly refined as the concept develops and additional details become known. The requirements are analyzed and deficiencies and cost drivers are identified and reviewed with the customer to establish a requirements baseline for the project. An objective of requirements analysis is to provide an understanding of the interactions between the various functions and to obtain a balanced set of requirements based on user objectives. Requirements are not developed in a vacuum. An essential part of the requirements development process is the OPSCON, the implicit design concept that accompanies it, and associated demands of relevant technology. Requirements come from a variety of sources, including the customer or users, regulations or codes, and corporate entities. This complex process employs performance analysis, trade studies, constraint evaluation, and cost benefit analysis. System requirements cannot be established without determining their impact, achievability, and lower level elements. Therefore, requirements definition and analysis is an iteration and balancing process that works both top down, or called allocation and flow down, and bottom up. Once the top level set of system requirements has been established, it is necessary to allocate and follow them down to successively lower levels. As the allocation and flow down process is repeated, it is essential that traceability be maintained to ensure that all system level requirements are satisfied in the resulting design. The resulting requirements database usually contains many attributes for each requirement and is also used in verification. Although it is an objective to avoid requirements that constrain or define aspects of the system implementation, it is not always possible. There are often necessary constraints that need to be reflected. This includes the following: standards. Identify standards required to meet quality or design considerations imposed as defined stakeholder requirements or derived to meet organization, industry, or domain requirements. Utilization environments. Identify the utilization environments and all environmental factors, either natural or induced, that may affect system performance, impact human comfort or safety, or cause human error for each of the operational scenarios envisioned for system use. Essential design considerations. Identify design considerations including human system integration, for example, manpower, personnel, training, environment, safety, occupational health, survivability, habitability, system security requirements, for example, information assurance, anti tamper provisions, and potential environmental impact. Design constraints. Identify design constraints including physical limitations, for example, weight, form or feed factors, manpower, personnel, and other resource constraints on operation of the system and define interfaces with host platforms and interacting systems external to the system boundary, including supply, maintenance, and training infrastructures. In defining requirements, care should be exercised to ensure the requirement is appropriately crafted. The following characteristics should be considered for every requirement. Necessary. Every requirement generates extra effort in the form of processing, maintenance, and verification. Only necessary requirements should therefore be included in specifications. Unnecessary requirements are of two varieties. 1. Unnecessary specification of design, which should be left to the discretion of the designer. 2. A redundant requirement covered in some other combination of requirements. Implementation independent. Customer requirements may be imposed at any level they desire. However, when customer requirements specify design, it should be questioned. A proper requirement should deal with the entity being specified as a black box by describing what transformation is to be performed by the box. The requirement should specify what is to be done at that level, not how it is to be done at that level. Unambiguous. Requirements must convey what is to be done to the next level of development. Its key purpose is to communicate. Is the requirement clear and concise? Is it possible to interpret the requirement in multiple ways? Are the terms defined? Does the requirement conflict with or contradict another requirement? Each requirement statement should be written to address one and only one concept. Requirements with and or commas, or other forms of redundancy can be difficult to verify and should be avoided, as it can be difficult to ensure all personnel have a common understanding. Requirements must therefore be written with extreme care. The language used must be clear, exact, and in sufficient detail to meet all reasonable interpretations. A glossary should be used to precisely define often used terms or terms such as process that could have multiple interpretations. Complete. The stated requirement should be complete and measurable and not need further amplification. The stated requirement should provide sufficient capability or characteristics. Singular. The requirement statement should be of only one requirement and should not be a combination of requirements or more than one function or constraint. Achievable. The requirement must be technically achievable within constraints and requires advances in technology within acceptable risk. It is best if the implementing developer participate in requirements definition. The developer should have the expertise to assess the achievability of the requirements. In the case of items to be subcontracted, the expertise of potential subcontractors is very valuable in the generation of the requirements. Additionally, participation by manufacturing and customers or users can help ensure achievable requirements. When it is not possible to have the right mix of developer, subcontractor, and or manufacturing expertise during the requirements generation, it is important to have the review at the first point possible to ensure achievability. Verifiable. Each requirement must be verified at some level by one of the four standard methods like inspection, analysis, demonstration, or test. A customer may specify the range shall be as long as possible. This is a valid but unverifiable requirement. This type of requirement is a signal that a trade study is needed to establish a verifiable maximum range requirement. Each verification requirement should be verifiable by a single method. A requirement requiring multiple methods to verify should be broken into multiple requirements. There is no problem with one method verifying multiple requirements. However, it indicates a potential for consolidating requirements. When the system hierarchy is properly designed, each level of specification has a corresponding level of verification during the verification stage. If element specifications are required to appropriately specify the system, element verification should be performed. Conforming. In many instances, there are applicable government, industry, and product standards, specifications, and interfaces with which compliance is required. An example might be additional requirements placed on new software developments for possible reusability. Another might be standard test interface connectors for certain product classes. In addition, the individual requirements should conform to the organization's standard template and style for writing requirements. When all requirements within the same organization have the same look and feel, each requirement is easier to write, understand, and review. Note that ISO IEC IEEE 29148 uses the term consistent instead of conforming, stating that the requirement must be free of conflicts with other requirements. While that is correct, a requirement cannot, in and of itself, be consistent. Consistency is more correctly a characteristic of the set of requirements. In addition to the characteristics of individual requirements, the characteristics of a set of requirements as a whole should be addressed to ensure that the set of requirements collectively provides for a feasible solution that meets the stakeholder intentions and constraints. These include complete. The set of requirements contains everything pertinent to the definition of system or system element being specified. Consistent. The set of requirements is consistent in that the requirements are not contradictory nor duplicated. Terms and abbreviations are used consistently in all requirements in accordance with the glossary. Feasible or affordable. The set of requirements can be satisfied by a solution that is obtainable within lifecycle cost, schedule, and technical constraints. Note that ISO IEC IEEE 29148 uses the term affordable instead of feasible, stating that the set of requirements are feasible within the lifecycle constraints of cost, schedule, technical, and regulatory. The INCOSE guide for writing requirements includes the word feasible, stating that feasible or affordable is a more appropriate title for this characteristic of the requirement set. Bounded. The set of requirements define the required scope for the solution to meet the stakeholder needs. Consequently, all necessary requirements must be included, irrelevant requirements must be excluded. In addition to the characteristics listed above, individual requirement statements may have a number of attributes attached to them, either as fields in a database or through relationships with other artifacts. Trace to parent. A child requirement is one that has been derived or decomposed from the parent. The achievement of all the children requirements will lead to the achievement of the parent requirement. Each of the children requirements must be able to be traced to its parent requirement and hence to any antecedent requirement and ultimately to the system need or mission. Trace to source. Each requirement must be able to be traced to its source. This is different from tracing to a parent because it identifies where the requirement came from and or how it was arrived at rather than which other requirement is its parent. Trace to interface definition. The interactions between two systems are described in interface definitions that are often contained in a document that has a title such as an ICD. The interface requirements contained in each of the interacting systems will include reference to where the interaction is defined. This attribute provides a link trace between any of the interface requirements to where the interaction is defined. Trace to peer requirements. This attribute links requirements that are related to each other than parent or child, at the same level. Peer requirements may be related for a number of reasons, such as the following. They may be in conflict, or codependent, or bundled, or a complementary interface requirement of another system to which the system has an interface. Trace to verification method. This could be a simple statement of the way in which the requirement is to be verified, or inspection, demonstration, test, analysis, simulation, or it could be a more elaborate statement that effectively provides the outline of an appropriate test plan. Trace to verification requirements. The verification method for each requirement simply states the planned method of verification, like inspection, demonstration, test, analysis, simulation. In addition to stating the verification method, some organizations write a set of verification requirements in addition to the system requirements. This is beneficial as it forces the systems engineer to consider how each requirement is to be verified, and in doing so helps identify and remove requirements that are not verifiable. Trace to verification results. The results of each verification will most often be contained in a separate document. This attribute traces each requirement to the associated verification results. Requirements verification status. It is useful to include an attribute that indicates whether the requirement has been verified or not. Requirements validation status. Requirements validation as the process of ensuring requirements and sets of requirements meet the rules and characteristics in the guide. Some organizations include an attribute field requirement validated to indicate whether the individual requirement has been validated. Priority. This is how important the requirement is to the stakeholder. It may not be a critical requirement, that is, one the system must possess or it won't work at all, but simply something that the stakeholder holds very dear. Priority may be characterized in terms of a level, like 1, 2, 3, or high, medium, or low. Priority may be inherited from a parent requirement. Criticality. A critical requirement is one that the system must achieve or the system cannot function at all. Perhaps can be viewed as one of the set of minimum essential requirements. Criticality may be characterized in terms of a level, like 1, 2, 3, or major, medium, minor. Criticality may be inherited from a parent requirement. Risk. This is the risk that the requirement cannot be achieved within technology, schedule, and budget. For example, the requirement may be possible technically, that is, the requirement may be feasible, but have risk of achievement within available budget and schedule. Risk may be characterized in terms of a level, for example, high, medium, low. Risk may be inherited from a parent requirement. Key driving requirement or KDR. A KDR is a requirement that to implement can have a large impact on cost or schedule. A KDR can be of any priority or criticality. Knowing the impact a KDR has on the design allows better management of requirements. When under schedule or budget pressure, a KDR that is low priority or low criticality may be a candidate for deletion. Owner. This is the person or element of the organization that has the right to say something about this requirement. The owner could be the source, but they are two different attributes. Rationale. Rationale defines why the requirement is needed and other information relevant to better understand the reason for and intent of the requirement. Rationale can also define any assumptions that were made when writing the requirement. What design effort drove the requirement, the source of any numbers in the requirement, and note how and why a requirement is constrained, or if needed, it is so. Applicability. This field may be used by an organization that has a family of similar product lines to identify the applicability of the requirement, for example, to product line, region, or country. Type. It is often useful to attach to each requirement an attribute of type, while each organization will define types based on how they may wish to organize their requirements. Examples of type include input, output, external interfaces, reliability, availability, maintainability, accessibility, environmental conditions, ergonomic, safety, security, facility, transportability, training, documentation, testing, quality provision, policy and regulatory, compatibility with existing systems, standards, and technical policies, conversion, growth, capacity, and installation. The type field is most useful because it allows the requirements database to be viewed by a large number of designers and stakeholders for a wide range of uses. At the beginning of the project, SE is concerned primarily with user requirements analysis, leading to the translation of user needs into basic functions and a quantifiable set of performance requirements that can be translated into design requirements. Defining, driving, and refining functional and performance requirements apply to the total system over its lifecycle, including its support requirements. These requirements need to be formally captured in a manner that defines the functions and interfaces and characterizes system performance such that they can be flowed down to hardware and software designers. This is a key SE activity and is the primary focus through system requirements review. During the requirements analysis, the support from most other disciplines, for example, software, hardware, manufacturing, quality, verification, specialty, is necessary to ensure a complete, feasible, and accurate set of requirements that consider all necessary lifecycle factors of the system definition. The customer is also a key stakeholder and validates the work as it progresses. Establishing a total set of system requirements is a complex, time consuming task involving nearly all project areas in an interactive effort. It must be done early since it forms the basis for all design, manufacturing, verification, operations, maintenance, and retirement efforts, and therefore determines the cost and schedule of the project. The activity is iterative for each stage with continuous feedback as the level of design detail increases and flows from the lifecycle concepts, particularly the OPSCON. The result of the system requirements definition process should be a baseline set of complete, accurate, non-ambiguous system requirements recorded in a requirement database accessible to all parties and captured in an approved release SYRS. The life cycle concept will also suggest requirements that are those dealing with operational conditions, for example, safety, system security, reliability, availability, and maintainability, human systems integration, environmental engineering, as well as life cycle constraints, for example, maintenance, disposal, that will strongly influence the definition of the solution elements. The SYRS, which is often called the system specification, is a baseline set of complete, accurate, non-ambiguous system requirements, recorded in the requirements database and accessible to all parties. To be non-ambiguous, requirements must be broken down into constituent parts in a traceable hierarchy such that each individual requirement statement is clear, unique, consistent, standalone, or not grouped, and verifiable. Traceable to an identified source requirement, not redundant nor in conflict with any other known requirement, not biased by any particular implementation. These objectives may not be achievable using source requirements. Often, requirements analysis is required to resolve potential conflicts and redundancies and to further decompose requirements so that each applies only to a single system function. Use of an automated requirements database will greatly facilitate this effort but is not explicitly required. During the system requirements definition process, it is often necessary to generate a snapshot report of clarified system requirements. To aid this process, it may be desirable to create a set of clarified requirement objects in the requirements database with information providing traceability from their corresponding originating requirement. Clarified requirements may be grouped as functional, performance, constraining, and non functional.